Nice. Well, thanks very much. Well done to David for pushing through with the voice there. Like everyone else, anybody who works at a university ends up with a cold. It's one of the fundamental laws of physics, actually. Mine wasn't too bad this time, but I thought I was immune. After what, 14 years of teaching, I thought I was immune to everything they could bring in, but they still managed to bring in new viruses. Anyway, yes, so I'm going to talk a bit about what we can see in the night sky over the next couple of months or so. This is a nice image of the Pleiades by Pete Lawrence. I always think when you see the Pleiades in the night sky that, you know, winter, cold nights, ice on your eyepiece, those are all way ahead of not long flight. I think this is a lovely image showing the gas. One of the interesting things about this, actually, we used to think that the gas here that's surrounding these stars is being illuminated by these stars, and we used to think these young stars form from this gas. Another theory now is actually these stars have already formed and they're just passing through a nebula and lighting it up. So maybe the Pleiades are a little bit different than from what we used to think. Okay, well, before we get on to the Skynotes proper, if you'll indulge me, I'll just like to tell you a little bit about my trip to the Lowell Observatory. I went with Pete Lawrence in July because Mars was so low. I've been using the university telescope to observe it, but the trees that are a mile away on the sports field were starting to block Mars. So I thought, well, probably had better head further south. So we went to the Lowell Observatory. Has anyone here ever been to the Lowell Observatory? Fantastic, isn't it? Well, the interesting thing, actually, Lowell is buried just off to the left there, so they don't just have his telescope and his books, they also have Lowell as well. And it's a fantastic resource. They're open every clear night, and they also open during the day as well, so they're doing a lot of public outreach for astronomy. And this is the refractor that they used. They allowed me to climb up this ladder to get a good view. Unfortunately, I forgot that I have vertigo, and by the time I got halfway up, I decided it wasn't such a good idea after all. But it is quite impressive. We've got all this brass and wood. It's a nice large Alvin Clark refractor. And using it was a joy. I'm delighted to report, so we had 2 clear nights. The astronomers that ran the telescope told us that the cloud and the rain arrived the day we flew in, and after the week we left, it all cleared up nicely again. So, but we did get 2 clear nights, and this is a picture of me using the telescope, and it does actually provide some very, very good views. And I was able to see Deimos and Phobos for the first time. The other thing as well, is the surrounding area of Flagstaff. If you venture out, there's Meteor Crater here, which I think is really quite a spectacular view. You get this wonderful, it's actually very difficult to get the whole crater. Has anyone here ever been to Meteor Crater? Yes? It is a fantastic place, and very, very eerie, because apart from the cafe and some people that are visiting, there's nothing for miles around, and when everybody goes in, it is utterly silent. So if you're in the area, as well as the Lowell Observatory, Meteor Crater is also worth a visit. And then there's this place, the Painted Desert. It really does look like something out of a science fiction scene. The reason it's called the Painted Desert is because it's got this very, very deep red rock. And actually, as an interesting thing, as you're approaching it a couple of miles away, you see the white clouds there. This perhaps hasn't come out so well in the image. The underneath of the clouds are glowing pink because of the light reflected from the Painted Desert. It really is a very interesting place. And because it's the US, you get some very extreme weather. This is a nice shot, I think, taken by Pete Lawrence again, showing the cloud structure. What isn't obvious from this is the deluge that happened 5 minutes later, and we were a good 15 minutes walk from the car. And what's interesting is the utter lack of self-preservation people have. Everyone there who had their big expansive cameras was taking off their coats to cover their cameras up, and were getting absolutely drenched. But all of this area is a fantastic place to look at, and if you're in the area, it's well worth a visit. So moving on now to the solar system, the sun. I had an email from Lynn Smith, our solar section director. She tells me that there's very little on the sun. Here's a theoretical simulation of what's on the sun. Here's an observation. As you can see, there is a very good correlation. The sun seems to be very, very inactive at the moment, and we don't really know why. One idea might be that we've seen the end of sunspots and that they're not ever going to appear on the disk of the sun again. I think that's rather depressing, because the only time I do solar observing is when we get these big sunspot groups there. But maybe the sun will liven up again, I don't know. But certainly at the moment it is incredibly inactive. We also had an eclipse of the moon. This occurred on the 27th of July. It was the day before my birthday, and I went up north to try and see it. Unfortunately, I was clouded out. Did anyone here manage to see it? Did anybody get it? No? Wasn't particularly good. As you can see so from the chart here, the moon was already in eclipse when it rose up, but it was certainly visible over Europe and most of Africa as well. I did find some images of it online. This I thought was quite nice. This is from Peter Anderson. I think this shows quite a nice image, and you've got the sort of dark orange colour at the top, but I don't think many observers in the UK had a lot of luck with it. This was a nice image. This was sent to me by Bill Leatherbarrow, our lunar section director. This is the Mare Crisium by Leo Ertz, and you've got I think this is a stunning picture, really showing this wonderful structure of this large lunar sea, and some nice craters as well. It's quite an impressive image, certainly one of the best images I've seen in a long time. I also quite like this image, which I think is yours, Nick, isn't it? I mean, did you wait for a while for the plane to come, or do you just live on a busy flight path?
I live on a fairly busy flight path. Those are all the planes in the stack waiting to go into Heathrow.
Oh, well, wasn't it nice of it to pass in front of the moon for you to get a nice image? So yes, so we had some nice images. And if you do browse through the Observers Forum, you can often pick out very interesting images that people have made, often whilst waiting to observe something they're actually observing. I think is quite interesting. So let's start with the inner solar system, Mercury. It's an evening object for most of November. It isn't terribly good at the moment. Greatest elongation occurs on the 6th of November, but it is incredibly low down, and inferior conjunction occurs on the 27th, and then after that the planet will appear in the morning sky. Nonetheless, Chris Hooker took some nice, I think these are nice pictures. Mercury is very much like the moon. We think it's very geologically inactive, and there aren't any sort of the changes going on the surface, not like we see with Mars and other planets in the solar system. Nonetheless, it is a nice challenge to be able to see it, and I think these images are quite good. They show some interesting detail on the surface. So we have a messenger image here on the right, and you can see that Chris has managed to pull out some very interesting details, which isn't too bad given how often low down the planet is and how poor the seeing is, because it's very close to the sun. We've had the Bepi-Colombo mission, which this was launched on the 20th of October. So some of my colleagues at Leicester are involved with this mission to try and understand a bit more about the inner planet to the solar system. So it's a joint ESA and Japan Aerospace Exploration Agency mission. So it's actually formed of two probes, two different spacecraft, and they're going to be put into different orbits. And I think one of the things they're trying to achieve is to try and understand a bit more about Mercury's interior. Mercury's interior is really, really fascinating. It has an enormous iron core inside, and nobody really knows why. It's very, very unusual, and we hope the Bepi-Colombo mission will tell us a great deal more about Mercury and perhaps how it formed and under what conditions it formed when the solar system was very young. It's due to arrive in December 2025, and as with most space probes, it's going to do various Venus and Earth flypasts before it gets to Mercury, but I think it'll be very interesting to see what data they get back. Had more luck with Venus. So for the first part of the elongation that's just gone, Venus wasn't too badly placed in the evening sky. Unfortunately, as inferior conjunction approached, the planet got much lower down. So the couple of drawings here, the ones here on the left by the section director Richard McKim, they show nicely the phase and some cloud markings. You really do have to be sensitive to the bluer end of the spectrum to see the markings of Venus. They come out very well in UV. I managed to get a couple of drawings just before dichotomy. That's when the planet appears almost like a half moon. It's interesting, there's an effect called the Schroter effect on Venus, where the observed phase is always a little bit less than the theoretically predicted phase, and that's because of Venus's atmosphere scatters the light, and the effect is more pronounced in blue light because the atmosphere scatters the blue light more. Unfortunately, I wasn't able to get any more observations after this. Next door's trees got in the way, and that was the end of my Venus observations. But good news, as of a month ago, they've cut them down, so now I have access to the western sky again. So I was very pleased with that, and I bought the chap next door a bottle of beer, who told me it was actually his wife that had nagged him into doing it, because she apparently had pears and she got fed up with the pears dropping on her when she was underneath the tree. So nonetheless, I now have a nice clear western horizon. Some UV images. So one on the right from Bill Leatherbarrow, we've got some nice structure in the upper clouds here. If you image Venus in infrared, you're probably not going to get an awful lot of details. It really is the UV that picks up the images. We have another nice one here from Manos Kadeisis in Greece, again with the UV filter, and you can see these faint upper cloud markings. This I thought was a splendid picture. This was taken by Chris Dole. Chris, you're here, aren't you? Where are you? There you are. But this is very good. How close to inferior conjunction was this?
About an hour and a half.
That's very good. That's very good. So you can see that the planet is practically between us and the sun. This is why we get this very, very thin phase. And in some cases, you can see the ring arcs continue down here. So we've now passed inferior conjunction. So this means the planet is now going to be in the morning sky. It's going to be still quite low down and hard to get hold of. But over the course of November, it'll improve. And by the end of November, actually, the phase here will have increased up to 25%, but the disk size is still quite large, an apparent disk size of 41 arc seconds, so worth getting up and looking out in the morning for. Planet Mars, I had a reasonable view of it. Now it's high enough. Have you noticed how high it's got in the sky now? It was, over the summer, it was incredibly low down, but now it's a lot higher. My 8-inch reflector shows some details. We have there the Syrtis Major. The Syrtis Major is a striking feature on Mars. It's actually one of the first, we think, one of the first features on Mars ever to be recorded telescopically. But it's a lot fainter at the moment because we have this big wide planet encircling dust storm that happened on Mars, and it seems that some of the features are still recovering from that. Above that, in both my drawing and then this image here on the right, this is by Martin Lewis. You can see the bright Hellas Basin. Normally Hellas is bright because it's filled with clouds, but at the moment it's just filled with dust from the fallout. So it's making the features of Mars incredibly interesting. I'm wondering if anybody noticed this in the news. No? We had, the first I got of it was an email. Occasionally members of the public write into the physics department, and somebody kindly wrote in to say that they had proof that there was aliens on Mars, and this was it. I had to write back and say, sadly, no, it's just an orographic cloud. Fox News really excelled themselves by stating categorically that volcanism had ended on Mars 50 years ago. Very, very precise figures, actually much longer than that. Nonetheless, it is an interesting cloud. This is one of the Martian volcanoes in the Tharsis Plateau. What's actually happened is because of the dust that I mentioned earlier in the Martian atmosphere started to fall down. That's called the Martian atmosphere, and you get these bright icy clouds collecting by the volcanoes. Sometimes they're even longer than this, and they collect and form this sort of interesting W shape, and I've seen these bright orographic clouds myself with my own 8-inch telescope. This is quite an interesting one because it does look like it's elongated, and it does look a little bit like it could be from a volcano, but we think that's incredibly unlikely, and that this is really just an orographic cloud which has been distributed by the Martian winds in the upper atmosphere. Although Mars has a tenuous atmosphere, it's still able to produce dust storms and winds, so it's certainly not inactive. So those images were taken by, I think, the Mars orbiter. This is an amateur image now, which was recorded by a Japanese observer. So you can probably just make it out here on the lower right. This is the Tharsis Plateau down here, sort of at the 4 o'clock position. And this is when this cloud, it's now within amateur telescopes. But I think it's still quite difficult to pick out, and you'll need a large telescope to see it. And we don't see this side of Mars now for, I think, about a week and a half. So, but who knows? It might continue to develop and become a more interesting feature, but it's certainly something to keep an eye out. Jupiter, well, I'm afraid Jupiter's past its best now. It's very close to the Sun, but we have had some nice images from BAA observers. I think these are very, very nice, showing the cloud belts and the moons. I think what's remarkable now is how frequently amateur astronomers capture detail on the surface of the moons of Jupiter. When I started out in astronomy back in the 90s, they were just interesting points of light, but now to have images regularly which show details on Ganymede and even Io is, I think, quite an achievement, and shows just how far amateur astronomy has come, certainly in the last couple of years. This, I think, is quite interesting. This is from the Jupiter orbiter, which is going around Jupiter, and according to my colleagues, making life quite difficult, because we now think Jupiter's even more bizarre than we thought it was to begin with. We've got these interesting, if you go through the images, we've got these interesting columns of clouds and these interesting structures, and John Rogers, another Jupiter enthusiast, is trying to use these to track the wind speeds in Jupiter. It's an interesting place because you've got lots of different jet streams, that all of which carry these winds and surface features. So it's becoming a very tremendous resource and recording a lot of interesting data. And I think the next Perigove 19 has happened, and the data from that is coming back. On to Saturn. About the same sort of altitude as Mars, but I have good news. Saturn, I think, now has reached its lowest altitude and is slowly climbing back up. So in a good 6 years, it'll be a viable target again. But it's worth keeping an eye out, just if nothing else, because it is such a profoundly beautiful object. On the left here is, we didn't just look at Mars when we were at Flagstaff, we also had a look at Saturn. And I think I had probably what was one of my finest views of Saturn through a telescope ever. And this is the drawing I made of Saturn on the left there, which shows considerable structure in the rings. It really was a startling image. I did try very hard to see the polar hexagon, but there was no hint of it visually, and I don't think it's something that can be seen visually. I think it's something that is only detectable with images. On the right here is, it's not just me that's been observing Saturn. Martin Lewis took this nice picture. The rings are currently wide open, so a very good target. And recently we've had some interesting storm activity. So we've had the brighter equatorial zone, and Mike Fuchs is collecting observations because Saturn's still just about visible in the evening sky. There's this very long-lived feature called the Northern Hemisphere storm. You can perhaps see it there sort of lower down. This has been very long-lived, and we've seen small storms appearing in the North Pole as well. So Saturn is continuing to be of interest. It's not for long now until we think a big equatorial storm might blow up. These tend to be sort of every 15, 20 years. You get these big equatorial storms in the equator of Saturn. Nothing yet, but again, the planet's worth keeping an eye out just in case. Uranus, this is actually probably the planet that's the highest, the best placed planet in the sky, because it's incredibly high up now, certainly a lot higher than the other planets. I made a drawing of it with the university telescope. We've got a 20-inch telescope. The drawing shows bands and brighter zones. I have to be honest, I'm not convinced by any of it. I think my eyes were probably playing a little tricks here. Uranus is very difficult. But people have been imaging it and have been getting detail. It's actually very easy to find with a small telescope. It's in the constellation of Aries at the moment, and if you look in the BAA handbook, you'll find tables showing you how to get to it. It's not difficult to find, and once you've found it, it moves very slowly in the night sky, so you'll be able to keep up with it. And a small telescope will reveal it as a little green disk. The satellites of Uranus, though, are very, very difficult to pick up, and you probably would need a large telescope to see those. Of interest is also the planet Neptune. So Neptune is the furthest planet from the Sun, as I'm sure we all know. Also, this is well placed now. It's in Aquarius, and all of November it's on show. And amateur astronomers have been doing a really fine job with this and imaging remarkably details in the clouds of Neptune. So this is an image again by Manos Kodesis, and he's managed to image what looks like a possible spot in the upper atmosphere of Neptune. We used to think of the ice giants as rather bland and quiet places, but over the last 4 or 5 years we've seen storms erupting on these ice giants, so they are worth keeping an eye out, because very often it's amateur astronomers that make follow-up observations or even detect them first. So possible new spot on the planet Neptune. What else do we have? Well, we have variable stars. So Chi Cygni, this is a lovely red giant that I've been observing, very easy to find in Cygnus. It's now currently at magnitude 8.6. This is, find a chart, you can see it's located just here. These kind of stars, they vary in brightness simply because they're changing their diameters. They're old stars that have reached the end of their lives, and they expand and they contract, and they do this very slowly, and as a result their surface brightness appears to change. So it's quite bright at the moment, and it will get brighter, so it will reach maximum brightness at the end of December. But it's one of these variable stars. It's actually much better found with binoculars than telescope. A pair of 10 by 50 binoculars is adequate to observe it. And all right, there might not be any useful scientific data to get from it, but it's still very nice to follow these long period variables, and the colours that change as well as they go is quite interesting to follow. Our Corona Borealis, this is still not recovered from its 11-year, 3-month low. Quite why, nobody really knows, but I've got a light curve here. So a light curve has the date on the bottom and the magnitude up the side here, and you can see it has this variation, and it reached its low quite some time back, but it's never quite gotten to full height. So we don't really know why that should be the case. Do you know its current magnitude, Jeremy? Oh well, it's slowly on the increase though, and we're wondering if it will reach its full brightness as it did 11 years ago, or maybe it will again only reach a little way up and then start to fade again. One final variable star, SV Sagittae. This has been fading steadily since 2003, 2004, and again the variable star section are very keen to follow this star. So you can see again from this light curve we had this dip way back in the past, and it was fairly constant, and then it started fading again, and again we're wondering, will it be as deep as the last fade, or will it not be? It might be the case that it stops at this sort of magnitude, or it might be the case that it continues going down. These observations are all very useful, so if you do make any observations, send them into the section directors, not just to variable stars, anything that you've been observing, because even an observation that you might think is routine might become very important later on. Finally, I'm only going to mention it briefly, the Geminids. You'll cover this more detail in the Skynotes. Yes, Chris? Nick, for the December meeting. But it's looking good this year for the Geminids. The moon is out of the way, and if you can stand the cold for a while, then it might be in for quite a treat. Again, it's probably going to be overhyped by the media, but it's certainly worth going out and having a look if you get a clear sky. So that's all for me this evening. My voice is now rapidly disappearing, so all that remains to say is thank you for coming to the AGM, and I hope to see you all at the Christmas meeting in December.